Welcome, everyone. This session is for data scientists and AI developers that want to customize models and deploy at scale to build high-quality and cost-effective agentic applications. In today's session, we'll also cover some of the new launches that were just announced in the AI keynote. So let's dive in. We are seeing two trends emerging in the market. First, there's rapid adoption of agentic AI in enterprise software apps. And this adoption is expected to go up from 1% in 2024 to 33% in 2028. That's a 33x increase in just 4 years. Also, organizations are expecting 15% of these decisions will be made autonomously by the agents by 2028, which would require a lot of compute and models that you can use to build out high-quality, cost-effective, and fast inference. Customers are increasingly relying on open-source models to build out these applications. However, even in spite of the large opportunity, as well as a clear line of sight on how to build these applications, we see majority of these applications never make it to production. Let's take a look at 4 key challenges that are blocking these applications from getting deployed to production. First, customers lack standardized tools to customize models. So they end up building and spending time building out these workflows. And when the time comes to take these workflows to production, because they've been put together with glue code, they have to rewrite these workflows with productionized tools to build out these pipelines that can help you build repeatable and scalable workloads, which often delays these projects and leads to a lot of manual effort. Second, customers lack tools that provide a unified view of model as well as the agent observability. With fragmented tools, it becomes much harder to debug any root cause issues of failure or when the behavior of the agent or the model deviates. Third, with model customization, the need for tracking the ML assets has evolved. Earlier, customers could monitor, track, and version the models and make sure they were cataloged in the right place and they could meet the governance and compliance requirements. Now, they need to also think about reward functions that are used in reinforcement learning, prompts, and so on, which often further leads to building out additional tools or integrations and delay the timelines. And lastly, customers need cost-effective, high-quality inference. And for that, building out an inference stack can be very complex. You have to find the right instance. You have to benchmark against different instance types to make sure you have the right cost-price-performance ratio. Then you have to do the same thing with the container or the different frameworks that you are using, which often leads to a lot of manual work and delay in getting these applications to production. And sometimes the ROI doesn't seem right because the inference is too expensive. So let's take a look at some of the key capabilities that SageMaker offers to address these. I'm Amit Modi, Senior Manager for Model Operations and Inference. And along with me, I have Shelby, who's the Worldwide Specialist Senior Manager for GenAI. And today, we are going to cover the key SageMaker capabilities that will help you address some of these challenges. And then Shelby will demo all these capabilities and bring them to life. So let's get started. Today, we are announcing the launch of Serverless Model Customization. Serverless Model Customization offers you the broadest choice of foundation models that you can use to customize the models based on your domain-specific or proprietary data of your organization. Along with these broad choice of models, you also have access to broad choice of different fine-tuning techniques that you can use to customize these models, and which includes reinforcement learning. And lastly, this experience is completely serverless, so you don't need to worry about reserving capacity or finding out where the GPUs are. You just kick off the job, and we take care of all the infrastructure for you. You can now navigate to SageMaker Studio, where you will find models. And under models, you will see the list of all the public known foundation models. And you will see 3 different experiences. You can customize these models through UI, SDK, or through the agent experience. In today's talk, we'll focus on the slides will primarily focus on UI, but we'll see a little bit more in the demos. Once you click on the UI, you will be navigated to a managed experience where you can select the base model, as well as the fine-tuning technique that you want to use for customizing the model. Once you select that, you can upload a data set. You can upload a data set here, or if you already have a data set that is tracked with SageMaker, you can just simply select that data set. Then you can choose the reward function that you want to customize. You can choose from a different variety of reward functions. And it also allows you to bring in code. You can manually type in the code, or you can bring in a Lambda that would do the reward function. And then you can simply select one of the Lambdas that you have already registered, and then you can get started with the fine-tuning experience. Behind the scenes, SageMaker takes care of checkpointing your jobs regularly. This ensures, in case there's a node failure in the cluster where we run these jobs, we will replace that node with a healthy node and resume your job from the last checkpoint, so it never overuses the compute, just the right amount. And in case the job fails due to some reason, you will always get a checkpoint at the end that you can use to resume your training jobs. Once you have built out these workflows, you can use SageMaker pipelines to continue customization and deploy these applications into productions. Today, we are also announcing new pipeline steps that are purpose-built for model customization and deployment. Deployment not only to SageMaker endpoints, but also to Bedrock, if you're using Bedrock for your inference techniques. With these new pipeline steps, you can accelerate your development by simply using the purpose-built pipeline steps, so that you don't have to write any glue code to leverage integrations with EMR Serverless for data processing, or Bedrock for deployment, or for training jobs within SageMaker. Pipelines are, if you already have an existing code that you wrote for your experiments in Notebook, you can simply annotate that code with @step decorator, or use our UI and upload this code over there to convert this into a fully functional pipeline. And pipelines are serverless, so you don't need to worry about managing any infrastructure. We log all the metrics to CloudWatch, where you can go and debug any issues. Next, we also announced yesterday the launch of Serverless MLflow. Serverless MLflow solves the problem of fragmented observability that we just talked about. When you are customizing your models, you can log experiments. You can also log evaluation metrics, as well as the agent traces once they're deployed. Serverless MLflow is fully managed. You don't need to spin up any servers. We take care of spinning up the compute for you. As the traffic on the inference or training grows, we scale up the Serverless MLflow and scale down when there's no need for the infrastructure. And also, there's no additional charge for MLflow. You can simply use SageMaker and log all the metrics in Serverless MLflow without worrying about any pricing implications. Serverless MLflow is also deeply integrated into your experience. So last, we looked at the fine-tuning experience where we kicked off a job. Once the job is complete or started execution, you will see on the model details, you will start to see the performance metrics. And MLflow is deeply embedded in here, so you can navigate from here into MLflow and see much more rich metrics if you want to take a deeper look. It's easily accessible under applications in case you want to leverage it for other workflows as well. So you can now see under a particular run all the experiments that you ran on different fine-tuning jobs. You can compare and contrast those metrics and have a deeper look, and then choose the right fine-tuning model for you. After you have chosen the fine-tuning model here, you can start to evaluate that model. Today, we are also announcing the launch of Serverless Model Evaluation inside Studio. As part of this experience, we offer popular benchmarks in the industry that you can use to evaluate your models. This experience is also completely serverless, so you don't need to worry about managing any instance types. You simply kick off an evaluation job, and the execution is done for you on your behalf. Let's take a look at how this experience works. So on the evaluation experience, you can simply choose one of the techniques. In this case, we'll choose LLM as a judge. It allows you to also define which metrics you want to use. So you can choose the right quality metrics. These are the most commonly used industry benchmarks. And you can, because responsible AI has now become such a critical aspect of shipping any models, we also offer some of these metrics out of the box that allow you to measure and put guardrails on your content. When you spin up an evaluation metric, you can provide a prompt template as well there, so that the model that you chose know exactly how to evaluate these requests. Once you kick off these metrics, you will see the results for not only the fine-tuned models, but also for the base model, both for the quality metrics as well as for the responsible AI content. This helps you to make decision on whether your model is actually performing better on both dimensions much more easily. Once you have deployed these models into production, and if you are also building out an agentic application on the top, if you're just building an agentic application, agent observability already is integrated into CloudWatch, so you can have all the dashboards to monitor the traces there. But if you're also leveraging model customization, you can use agent core observability to emit metrics in open telemetry format into managed MLflow or partner AI apps. We'll take a quick look at how you can use those metrics in managed MLflow and partner AI apps. So here's a screenshot for what the experience would look like with managed MLflow. On the left side, you will see a complete trace tree, starting from invoking the agent at the top and drilling down through the workflow build process, capturing each LangChain operation, and showing tool calls and the calls to the multiple assistant interactions, assistant 1, assistant 2. And this hierarchical view gives you the complete visibility into each step of the agent. We also offer partner applications as managed capabilities on SageMaker. So you can simply launch them and get started. So some customers that choose to use CometML for tracking their experiments, evaluating their models, can also log these metrics into CometML and then use that information for both agent as well as ML to debug the root cause. CometML also offers certain key capabilities like ability to optimize the prompts by giving the goal and also optimizing the agents. So it takes the end goal and continues to run the evaluations for you and optimize the prompts till you have the best prompt. We also enable deep checks that allows you to test, evaluate, and monitor LLM apps as well as agents. It provides a much more comprehensive view. You can also manually and automatically annotate all the interactions with the LLM and get a much more comprehensive report, which allows you to much more easily root cause and debug issues. And lastly, we also have Fiddler that allows you to do agentic observability and then root cause it back down to like every single model customization experience. SageMaker also offers capabilities to deploy your models, and today we are announcing easy integration with Bedrock, so you can simply, from your SageMaker Studio, kick off a job to deploy the models on Bedrock. Along with that, you can continue to leverage SageMaker endpoints for deploying multiple adapters for your model onto the same endpoint. We'll take a little bit of a deeper dive into this capability in a minute that can help you save on your costs. And you can use different techniques to further optimize the performance of this model. There are various different techniques offered, and we'll do a deeper dive in a bit on speculative decoding, which is one of the key techniques to minimize any latency for your applications. So let's take a look at the first key benefit for SageMaker endpoint. You can deploy multiple foundation models on the same endpoint. This ensures you have one endpoint, and as your use cases continue to grow, you are just continue to use one endpoint. This can help significantly reduce your cost. And as the traffic grows, SageMaker offers capability to emit metrics for each foundation model. So you can build out auto-scaling policies for every single model, and as the traffic grows, that particular foundation model scales to other instances, making sure your costs are minimized. This can help you save on the cost up to 50%. And it has we recently launched certain capabilities that allow us to cache the model weights, which ensures that the auto-scaling is much more faster. Next, let's take a look at one of the key techniques that we recently launched to help you optimize the latency for your applications. So typically, customer expectation for inference is that it's fast. However, foundation models generate one token at a time, which leads to slower inference. The way speculative decoding works, you have a foundation model and a draft model. Draft model is typically a smaller model. Draft model generates some tokens for foundation model to review. Foundation model then reviews those tokens and assigns probability and then accepts certain token and rejects some. So let's take an example here on how that would work. So let's put a prompt here, the cat. The draft model generates the response for that token. Foundation model evaluates these tokens and accepts some of them. This is a simplistic view. You can use the draft model to actually generate multiple variations of that. And the capability that we launched recently allows you to not only just generate these tokens, but also to fine-tune the draft model on your traffic, which helps you get higher quality responses from the draft model. So let's take a look at how that capability works. So this leads to latency reduction to up to 2.5x throughput without losing any accuracy, because you're able to fine-tune the draft model on your traffic. So let's take a look how it works. You can bring your own data set, or you can use one of these SageMaker curated data sets. You can kick off the fine-tuning job on the draft model. It's an async job that runs in the background. Once the job is complete, it publishes the evaluation metrics. You can review the evaluation metrics and choose to deploy the draft model on the same endpoint. So there's no impact on your cost, and the draft model gets deployed on the same endpoint. And then the draft model generates these tokens that foundation model can evaluate and accept, so you don't lose any accuracy and continue to see this latency improvement. Lastly, we also launched new capabilities that allow you to not only track models, but also generative AI assets like data sets, reward functions. Similar to models, now you can track all the data sets as well as validators that Shelby will walk through in her demo. And you can not only track these assets, but you can also track lineage. So you can track each version and the lineage for all of these assets. On that note, now I'll hand it over to Shelby to walk us through all these capabilities. Good job.
All right. Let me swap over. All right, so, the thing, by the way, they do. What happened to my screen? There it went. Gosh, connections. Okay. Sorry about that. But thank you all for joining. I think we're probably standing in between you and lunch, or maybe you've already had lunch, but thank you for joining anyway. So for this demo, what we're going to go through is a couple things, right? It's going to be an end-to-end demo. We're going to look at model customization and then integrating that model into an agent. That being said, we're going to use a use case, a really simplistic use case of a medical triage agent. Oh, goodness. The demo gods hate me today. But we're going to do a medical triage agent. So we're going to take an open source model, basically, customize it or adapt it to our specific task. And in this case, it's going to be an agent that is able to triage medical symptoms prior to allowing a patient to book an appointment and or paging an on-call physician. So it's going to be in two parts. We're going to start first with model customization, focusing on the newer model customization experience. And then in the second part, we'll look at how to integrate that with agents, specifically Agent Core. And in this specific demo, we're going to focus a little bit more on kind of the end-to-end capabilities. Keep in mind, over the next few days, there's going to be a lot more sessions that dive deeper into different specifics of the new model customization experience, from like the different techniques as well as the different evaluation techniques as well. So that being said, let's get started and hope the Wi-Fi is going to work out for me. So like Amit mentioned, there is assets. So assets is new in being able to track and manage different assets that are part of your experiments. Datasets is a key asset. So you'll see inside, if we click on datasets, basically it'll show all the datasets that you've uploaded that are available for use for different fine-tuning workloads. You can also see inside there maintaining multiple versions, right, across different experiments. You may have multiple different versions of the process data that you'll utilize as input into your fine-tuning jobs. So to upload a dataset, you just click Upload Dataset, enter a descriptive name, and then you can either upload directly from your local computer or from an S3 location, right? If you already have your data in S3 that you've put, you can upload it from S3. In this case, we'll just do a local upload from my computer. And then you just hit save. You can hit save and then hit create. And what that does, basically, you'll see inside here, now that data set is uploaded, you can upload new versions as you iterate through your experiments. So that'll be used as our input into the model customization job that we'll kick off. The other thing I want to point out prior, Amit talked about new serverless MLflow. So you can see, if you're used to the interface, you'll now see a new app servers tab inside MLflow. And this is where all of your serverless MLflow app servers reside. You can see here I have a default one, but I also have a custom one that I made for this demo. So we'll specifically use that one. And what will end up happening, and you'll see through the model customization demo, is all of the model performance metrics are going to automatically log into MLflow, as well as all the evaluation metrics that you run against your fine-tuned models will automatically run into MLflow, which makes it really easy for comparison, visualization across experiments to understand which model you eventually want to deploy and test out with your agent integrations or deploy into high-level environments. So that being said, let's go ahead into the new customization experience. So you'll see inside here, there's a range of models that you can customize, including the the previous existing models, right? Same with ML, DL, all those models are all in one spot. All the models that you have customized will end up over here in My Models. So you can see all the models that you've done customization with over in My Models, get details about them, and we'll go into this later. But let's go ahead and kick off a model customization job. As you can imagine, it takes a little bit of time to run these jobs. So I do have some pre-baked models, pre-baked versions that we'll use in cooking show fashion. But to start with, you basically just hit customize. So you can customize through the UI, which is what we're going to do in the demo. But you can also customize through AI Agent, which was announced this morning. It is in preview, but the ability to use natural language to kind of develop a guided workflow for fine-tuning customization. You can also customize through code as well. So all of this does have an SDK available for those that kind of prefer a programmatic experience. That being said, let's go customize through UI. So basically, you'll just enter a descriptive name for your model. I'm going to just call it medical triage. I have a couple in here. And here is where you can see the different customization techniques. And like I said, through the different sessions over today, tomorrow, they're going to go into more detail on a lot of these different customization techniques. But you can see the ones out of the box today are supervised fine-tuning. We have DPO. We also have reinforcement learning with verifiable rewards, as well as reinforcement learning with AI feedback. In this case, we're just going to do supervised fine-tuning for today. So you click what customization technique you want to use. You can upload your data set here, or in this case, we're just going to point to that data set that we just uploaded before. And then the version that you want to use too. We only have one version in this case. And then here's where you can modify some of the hyperparameters in the configurations across your different training experiments. In this case, I'm going to just go with the default parameters out of the box, but you can modify the different hyperparameters here. And then we'll also point to the MLflow app that you want to use. So you can see, again, here's the default one that's created, and then here is the one that I created specific for this session today. And then you can, of course, adjust the experiment name, have more meaningful titles inside there so it's easier to find inside MLflow. Here's also where you can adjust the security settings. As usual, right? Although it's serverless training under the covers, you can also specify to run inside your VPC, also specify the type of encryption that you want to use on the volumes. And then just submit. And what that does, basically, it'll kick off a serverless training job. So you can kind of see one in progress here. And as it kicks off and starts going, you have the logs here. They're not available yet, but the log's there to watch, and if you want to do things like early stopping and that sort of thing. But that being said, let's look at some pre-baked versions. So I'm going to go over here. I'm going to look at this one. This one was trained on a full data set. In this case, we're just using an open data set, which is trained on some basically medical symptoms and then medical kind of diagnosis. Let's view the latest version. So here's where you can see inside. These are all your different versions. You can move between versions, clearly, as well as different tabs. There's performance. You can see in this case, it went off the rails a little bit, probably overfitting a smidge. If I had been watching it, could have done early stopping, but I can also tweak the hyperparameters a bit too, right, to avoid some of that. Also, evaluations. So you can see here, this is where the evaluation jobs, and there's a lot of different evaluations available. In this case, we ran some out-of-the-box benchmarks as well as another full evaluation. But if you want to run an evaluation, basically you just click evaluate, set up a descriptive name again, and there are the 3 evaluation types like Amit talked about. So there's LLM as a judge, and within that you get to specify which model you want to have as your judge model. And then with that, you also specify the metrics that you want to evaluate against, as well as the ability to bring your own custom metrics as well in LLM as a judge. The other kind is custom score. So this is where you can bring your own custom scoring code. You can also use a couple of the built-in metrics. Specifically, they have some around code execution and math answers. In this case, we're going to just use some out of the box benchmarks to demo. Specifically, we'll use multitask language understanding, and we'll narrow that down more specific to the task that we're trying to fine-tune for, which is inside like the medical domain. The other thing I'm going to click to is compare against the base model. So this is important when you want to evaluate against the base model to see if it makes sense even to do fine-tuning, right? So you want to compare it against that base model. In this case, we're using Qwen 2.5. So we want to compare all our evaluation metrics against that base model to make sure that we are actually making progress on having a more fine-tuned model. So in this case, it does test across 10 subjects. It's not super useful in our use case, so what we'll do is we'll narrow it down to clinical knowledge. And then you can also specify advanced configuration parameters as well within your evaluation. So things like top P, top K, as well as security settings again, right? So the ability to run these evaluation jobs, they are serverless, they run in the background, but you still have the ability to run those inside your VPC as well as specify the type of encryption. So that being said, I'm just going to hit submit. So once you submit, you can see what it does is automatically create an evaluation pipeline for you behind the scenes. You don't have to deal with the pipeline that gets created, but it takes care of those steps that are involved with passing data in, passing it out, publishing those metrics into MLflow. So that being said, so we've done our training, right? Let's assume we've done our training, we've done some evaluation. Let's look at some of the metrics that flow over into MLflow automatically. So first we'll look at the model performance metrics. These are just the pre-baked versions that I have from the actual training performance themselves. So let's go ahead and just kind of compare against the 4 versions that we have. And within here, you'll see more of like a table format, right, of the different versions and some of the metrics that are captured during your training cycles. So things, and as well as your hyperparameters. So like how many epochs you ran with, like the loss, validation loss, test loss, all of those different metrics. But you can also go into those same models and actually do more kind of visual comparisons, which are helpful in evaluating against each other. So let me, oh, sorry. It's the danger of live demos. All right. Oh, sorry. All right. So inside here, here's the visualization. So this is where you can visualize across the different versions to like compare the loss that you're seeing across all the different iterations of fine-tuning. So that being said, so this is the model performance itself, right? And then there's the evaluation metrics that we just saw too, where we use the MMLU clinical knowledge benchmark to benchmark against. So you can also compare those metrics inside here as well. So to do that, I'm just going to hide the model performance metrics. We could keep them on, but just to kind of highlight, here are the model performance metrics. And you'll notice I'm also highlighting the base model too, because we want to be able to understand, is this model actually performing better than the base model, the base Qwen model, for the particular task that we're trying to solve for. And in this case, we're using, there's clinical custom. You'll see inside here, there's LLM as a judge. There's MMLU college knowledge as well. In reality, you're going to look at this model across a bunch of different performance metrics, right? This is just one example, you'll see, where we're basically doing it across one of these evaluation metrics. So you can kind of see inside here. Oops. In this particular case, this first model here, the first version, is performing best against that particular benchmark, right? The clinical knowledge benchmark. So that way you can do that across different metrics, across different evaluations to ultimately decide which model you want to test out a little bit more within your agentic workflows and or move into production. So that being said, now that we have done evaluation, let's go back to our model again. And now we can go into deployment. So assuming you want to deploy this, integrate it with agents, you would go here into deployment, and then just click deploy. And here is where Amit mentioned you can deploy to either SageMaker or Bedrock, which is a very nice feature. Let's assume in this case, so at Bedrock would be through custom model import, right? Through SageMaker, let's just assume we're going to create a new endpoint. So here you just enter a name. You can choose the instance type still, right, like you can today, or just accept the default recommendation. Again, the advanced options are available to you in terms of the max instance count, the security settings, all of those different items, and then just hit deploy. And what that'll do is deploy a SageMaker endpoint behind the scenes that's now available and ready for use and integration into any agent workflows or just direct application integration. The other thing to point out inside here is the lineage tab, which Amit talked about. So the nice part about all of these different tasks and steps that are leading up to it, because there's a lot of moving pieces, as you can see, from the training to all the evaluations that have to happen. Here you're able to track and maintain complete lineage. So as an example, if we click on the first one, model artifacts, in this case it is the base Quen model, right? So you can see exactly what version of the Quen model was used for this fine tuning. And then as you kind of progress along through, like you can see the training job that was used, all the metadata is stored and collected that contains the complete lineage. And you'll see it tracks all the way back through pipeline execution and deployment. In this case, the deployment isn't actually finished yet, but it does track all the way through to deployment, which is really nice for traceability and maintaining that end-to-end lineage. So that being said, let's just assume we have it deployed out, and now we're going to integrate it with our agent workflow. So these are the steps that we just took, right? Doing all the experimentation, ultimately deploying to SageMaker AI. Again, you could deploy to Bedrock. It depends on what you're looking for. Some of the adapter-based inference is really nice, cost-compelling feature, especially for fine-tuning. But you can also import into Bedrock, too. So in this case, what we're going to do is we're going to take that SageMaker endpoint that is now hosting our fine-tuned model that's specifically adapted for the task inside the medical domain that we're looking for. And we're going to assume this is experimentation at this point and use the Strands SDK. Keep in mind when we're going through this, you could just as easily use any of the other frameworks that are supported by Agent Core, whether it's LangGraph or CrewAI. I'm just showcasing it with Strands. So here what we're going to do is create an agent, and we're going to create a couple dummy tools on the back end and see if the agent's able to make smarter decisions about whether those symptoms are urgent and potentially need to page the on-call or go to urgent care, or if they're going to go ahead and let them book an appointment that's a less urgent appointment. And we're going to also look at MLflow on the back end for agent traces. One thing to keep in mind, so MLflow does do agent traces, also agent evaluations. And it kind of depends because also Bedrock Agent Core has great built-in observability features as well as evaluations that were announced yesterday, I think. So it kind of depends. MLflow may be a good option if you are dealing with models and agents, whereas if you're only dealing with agents, Agent Core using those native built-in capabilities make more sense for your use case. So that being said, there's a bunch of dependencies, installations, but one thing I wanted to show is this is the model configuration with Strands SDK. So just like a Bedrock API kind of endpoint, you can create a model that is based on a SageMaker endpoint as well. So here you'll see, actually let me blow this up a little bit. So you'll see there's a specific integration with Strands called SageMaker AI model, where you specify the endpoint name as well as the inference component name in the case of where you're taking advantage of that adapter-based inference. And then we're just going to create a super simple agent, no tools behind the scenes, just to see how our model performs against the task. And it's the fine-tuned model, right, without tools. So here you'll just say I need to book an appointment. It does a reasonable job, right, in responding, but it doesn't necessarily have the smarts to actually go and do anything about it, right? To actually look for availability or page an on-call doctor, that sort of thing. So what we'll do, we'll implement some conversation management, right? And this is just, again, part of the Strands SDK. So some conversation management, async operators for streaming, so maintaining some of those conversations. And then we'll, again, try to hit our endpoint on the back end. And you'll see you would just, get a response again, saying go to the nearest emergency room, that sort of thing. But once again, there is no actual tools to be able to take any action on anything. So what we'll do to fix that is add some tools. You'll see these are some dummy implementations of tools. We have a booking availability tool. We have a booking tool and then a page on-call tool. But what we really want to see is if our agent is smart enough to select the tool, right, based on kind of the input that is provided. So you'll see with the addition of tools, some additional prompt engineering around that. We'll then actually build out the agent. One thing we're going to do before that is with our more kind of advanced prompt is register the system prompt. So one of the common challenges we hear from customers is the ability to kind of share and manage prompts that are used as part of your applications. MLflow does have prompt management capabilities within it. So once we've settled on a prompt, a reasonable prompt that we're going to use for some testing cycles, we can then configure that system prompt inside MLflow. So this code here, you can see, is basically just registering that prompt into MLflow. And you'll see here's the prompt name. And if we go over and look at it inside MLflow, this one's the test prompt. You can see this only has one version, but what it'll do is maintain multiple versions of that prompt. What's nice about that is, I don't know about you all, but like sometimes when we get in a room and we're like building out something, everyone's just sharing prompts through Slack or whatever the case is. This allows you to actually, one, version it, but also share it more easily, right? So you can actually share your prompts across your team. In the production case, it's pretty critical for like tracing lineage though, right? In this case, we're just saying it's a test prompt and we're doing some versioning. So now that we've done that, we've created our prompt alias. We'll now create the agent using our tools, right? So in this case, we're going to take those dummy tools that we created and make those available to our agent. And again, our agent is backed by that fine-tuned model on the back end. So to do that, we'll just basically make the tools available here. So this is our booking availability, our paging, our on-call. And then we'll again invoke our agent using tools this time though. So in this case, I need to book an appointment. And here's the agent response. It's directed, right, in our prompt. We've told it, like, you need to make sure that you gather the symptoms before actually letting a patient go ahead and book. So now you can see we're getting good responses. But one of the things in MLflow that you can do is also tracing of agents to be able to verify that those tools are being called, right? Which is really important as I'm sure a lot of you are building agents today, and being able to trace the thought process, when it's calling a tool, when it's not, when it's pretending to, is really important. So if we look at some of the agent tracing inside MLflow, you can kind of see, here, it sounds like you're, experiencing it for days. It's a medical issue. Here you can see where this is just the outputs that. You can see in different cases, booking availability somewhere in here. Oh, no wonder. So sorry, I'm in the wrong experiment. Is this the one? Yeah, there we go, sorry. So here you can see executing on call. So there is a medical emergency, so you can see the tool was actually called. And here you just see like where it's interacting, obviously, with your model behind the back scenes, but then where the tool is actually called on the back end. So the tracing is really very valuable in debugging to know when a tool is being called, when it's not, and what the actual logic flow of your application is. And again, like I mentioned, you can use Agent Core observability and that sort of thing as well, now that they've kind of released there. This is just nice when you do need to merge together your model experimentation, all the metrics between models and agents. So that being said, so we developed it on Strands first, which is pretty common, right, for development, but now we want to deploy it so it's scalable. So using Agent Core runtime to actually host that agent. So in this case, what we're going to do, it looks very similar to the last one, but with Agent Core, we're going to use the runtime agent, like I said, to host the agent, but also Agent Core identity to manage the user interactions. So to do that, we just write out our agent code, right? So it's a Python file of our agent code. And again, we're using the SageMaker endpoint name, as you saw before. So we're actually pointing to a SageMaker model on the back end. We're making our dummy tools available as well, and setting up some Cognito user pools and authentication. Here is where we'll register the system prompt for production, which is something I definitely recommend for just kind of reliability and knowing what prompts, what prompt versions are attached to any given agent. So we'll register the prompt again, but in this case, we're going to register it as a production prompt. So you'll see here again, it's only one version, but it can maintain multiple versions, right? So you see here, this is the agent prompt that is tied to that particular agent. Sorry, it's a lot to scroll through. And then we're going to deploy our agent. So we're deploying our agent again to Agent Core Runtime. In this case, I'm using the helper tool, right, to launch the agent. But you'll see inside here, we're pointing to our entry point in our Python code. We're also pointing to the agent name will be agent prod, medical triage agent prod, and then using the authorization config. And then here's where we're actually launching that. So once it's actually launched, we can then test out our endpoint. One of the things I would recommend doing in terms of traceability, most of the time this is going to be deployed on a CD pipeline in the back end, right, in reality, versus deploying this out of a notebook when you're ready to go to production. But I would recommend tagging that SageMaker endpoint with the agent ARN and the agent ID that comes back. So that way you know for any given endpoint out there, here's the agents that are using or depending on that endpoint. Because those dependencies are tough to maintain if you don't have that level of tracking. So here we're just tagging the endpoints with the agent ARN and the agent ID. And then here you can see kind of the list tags. So you can see where we've tagged it. And then we're just going to use the agent. So in using the agent, we'll do the same thing, right? We're going to invoke the agent. We have some invoke agent code, invoke endpoint code. And then we're just going to send prompts in like we did before. But this time it's running on scalable agent core runtime compute. And again, we'll go back. It's going to, because we set it up for MLflow for agent tracing, you can go back into MLflow and see the production level traces as well. And the same thing, basically, right? You can see when it's calling different tools, when it's not, and collecting that automatically. So this is just going through some iterations, making sure that we call it when we should and not when we shouldn't, right? So like a stuffy nose, that really probably shouldn't be an urgent call, right? So in this case, they're basically just saying, you know, it's not available for day, we can book it for another time because it's not a medical emergency. So that's kind of it. That's basically showing kind of an end-to-end of using a fine-tuned model that's adapted to a specific task within your domain to get better performance, as well as integrating it with an agent workflow. One of the things to keep in mind, we talked about lineage, we talked about traceability, right? What you saw on model customization, it has the nice lineage that's automatically captured. Some additional things to keep in mind, though, with your agent workflows is, I showed it in a notebook today, right? Which is great for experimentation. In reality, like I said, you're probably going to include that in like a continuous delivery, continuous deployment pipeline when you go to production deployment for agents. And there are, as you can see inside here, a lot of different versions to consider. The nice part, that left side of the picture is all taken care of with model customization now, with lineage, that full end-to-end lineage. On the right-hand side, just something to keep in mind, with your CD deployment pipelines, capturing all those different versions across agents too. And we did a very, very simple agent, right? Let alone like multi-agent orchestration workflows. So capturing all those versions and the dependencies so that you know, like we did tag the endpoint as one example. So you know with that endpoint, we have X number of agents dependent on that endpoint. So that being said, we went through a lot in a short amount of time. But yeah, thank you all so much. I'm going to turn it back over to Amit. Oh, actually, one more thing, if you want the code examples. I will say I could not push those before this meeting because I had a meeting. I will push them today because I had new launch things in it that I couldn't push. So apologies, but yeah, if you just get a screenshot of that, I'll post the code by end of today. All right, Amit. Oh.
Thank you, Shelby. We'll do a quick recap, and then we'll open the floor for like any questions that you may have. So yeah, sure. Okay. Just to do a quick recap of what we covered today. First, SageMaker now offers fully managed and serverless experience for customizing your models from training to evaluation and then deploying the models. With SageMaker AI inference capabilities, you can host multiple models on the same endpoint, auto-scale easily, and use the optimization techniques to make it cost-effective for you. You can get end-to-end observability for your model customization as well as agents with managed MLflow, serverless MLflow, or partner AI apps. And you can build scalable and repeatable workflows with SageMaker AI pipelines using the new steps that we launched today. And lastly, you can also now not only track model track and audit the versions of the models, but also of the AI assets that are used in the model customization. Here's the barcode for the same storyboard. It's not the exact demo, but it's the storyboard. It walks you through the example step by step. Feel free to check it out. And if you have any questions, there are 2 mics over there in the center of the room. Feel free to bring up the questions. What's left?
All right.
Cool.
Thank you all.
Thank you, folks.